Welcome to this explainer. I'm so glad you're joining me today because, well, we're looking at something truly massive. We're going to explore the Nancy Grace Roman Space Telescope's Galactic Bulge Time-Domain Survey. Specifically, we're going to look at the immense data engine running behind the scenes to hunt for the elusive Einstein ring and hidden exoplanets. It's called the Microlensing Science Operations System, or MSOS for short. Here's our agenda for today. First, we'll look at the Galactic Bulge Firehose. Second, enter the MSOS pipeline. Third, daily mode, rapid triage. Fourth, end of season, the bigger picture. Fifth, end of survey, final legacy. And sixth, the community science bounty. Section 1, the Galactic Bulge Firehose. Let's talk about the intense data collection phase of this survey, because this is definitely not your standard point-and-shoot astronomy. Imagine pointing a telescope at the absolutely most crowded part of our galaxy, the galactic bulge, taking 67-second exposures across multiple fields and returning to the exact same spots every 15 minutes, 24 hours a day for a roughly 70-day season. It creates a completely chaotic, overwhelming influx of raw imagery. So how do you process a fire hose of starlight? Okay, let's dive into this. That Firehose translates to 4.2 terabytes of level 2 calibrated data arriving every single day during the microlensing survey. To put that into perspective, that is like downloading over 1,000 HD movies every 24 hours. Over the 6 planned seasons, we're talking about 1.9 petabytes of image data. This is millions upon millions of stars, with their light being measured over and over again just to catch the tiny, fleeting magnification of a microlensing event. Section 2. Enter the MSOS pipeline. To handle this staggering volume of information, we obviously need a specialized engine. MSOS stands for the Microlensing Science Operations System. Hosted at the Science Support Center, or SSC, at IPAC, MSOS is the core processing engine. Its entire job is to ingest those 4.2 daily terabytes of level 2, or basically cleaned up data from the Operations Center, and generate level 3 image mosaics and level 4 final exoplanet catalogs. It's quite literally the machine built to identify and characterize these extremely rare planetary microlensing events. And this brilliantly illustrates the path that data takes. You have the raw data, the K-band telemetry, coming down from the Roman spacecraft, flowing into the Science Operations Center, or SOC. The SOC handles the initial calibration to create level 2 data. That level 2 data then flows straight up into the SSC, where the MOSS pipeline goes to work, eventually pushing level 3 and 4 products back down to the SOC for the archive. Let's move along and see how this builds our timeline. Because it's an ongoing survey, MSOS doesn't just run once and call it a day. It actually operates in 3 distinct temporal modes: the daily pipeline, the end-of-season pipeline, and the end-of-survey pipeline. And this structure is going to frame the rest of our explainer today. Section 3. Daily mode, rapid triage. In daily mode, it is all about rapid triage, and the system has to move incredibly fast to keep up. To preserve the critical temporal information, because microlensing events can change really quickly, the daily pipeline begins work the exact moment it receives level 2 data. It's fully automated, designed to complete its processing within 12 hours, and requires that archival products are returned to the SOC within 48 hours. On a daily basis, the pipeline updates the point spread function, or PSF model, which is basically how the telescope smears starlight. It fits the stars and updates the light curves. But every 8 days, it runs a special cycle. It creates a super-sampled reference image, updates the object catalog to see if any new sources have popped up, and measures higher-order PSF moments, adjusting for optical distortions, which is absolutely vital for Roman's complicated optics. It even acts as a safety net, flagging algorithms that might be failing. Section 4. End of season, the bigger picture. Once a 70-day observing season wraps up, the pipeline shifts gears entirely. So the crucial point here is the contrast in the outputs. While the daily pipeline gives us rapid light curves, positions, and basic PSF fits, the end-of-season pipeline actually synthesizes all of that data. It produces comprehensive variability catalogs, evaluates the physical parameters of the microlensing models, and actively measures the pipeline's own detection efficiency. During this phase, MSOS time trends all variable objects and refines the photometry specifically for the detected microlensing events. Fascinatingly, it also characterizes its own reliability by playing a sort of digital hide-and-seek. It injects simulated events into the data and sees if the pipeline successfully recovers them. It literally tests its own false positive and false negative rates to ensure absolute scientific accuracy. Section 5. End of survey, final legacy. Now, fast forward to the end of Roman's multi-year primary mission. The final pipeline mode kicks in. At the end of the entire survey, MSOS runs a massive final pass. This locks in the scientific legacy by calculating exactly how these stars physically move in 3D space, producing relative proper motions and distance parallax estimates for all cataloged sources. With multiple seasons of data spanning different telescope orientations, the positional accuracy becomes absolutely incredible. Now, MSOS handles the uniform, bulk processing, but it works in tandem with the Argus Project Infrastructure Team, or PIT. While MSOS provides the robust core products, the Argus PIT provides what they call value-added enhancements. For instance, if a source wasn't detected in the initial MSOS 8-day stack, MSOS won't make a light curve for it. So, the Argus PIT will step in to create bespoke, tender-loving care light curves, perform detailed multi-star lens flux analysis, and explore complex degenerate posteriors, which is basically untangling really complicated overlapping mathematical probabilities.
Section 6. The Community Science Bounty.
The MSOS pipeline is designed to find exoplanets, but doing so creates a massive secondary benefit for the broader astronomical community. Now, what's really interesting about this is a truly revolutionary fact. There is a zero proprietary period for all Roman data. Within days of those level 1 and 2 files hitting the archive, and within the 48-hour turnaround of the daily MSOS catalogs, anyone in the world can access this data. Because MSOS tracks millions of stars every 15 minutes, it's going to uncover an absolute zoo of variability. We are talking about millions of non-microlensing variable stars. Furthermore, it's going to find thousands of binary microlensing events. Unlike traditional transit methods, microlensing selects objects by mass, not light. This means the community gets a complete census of binaries like brown dwarf pairs or systems containing stellar remnants, regardless of how faint they are. The citizen science potential here is just off the charts. The Microlensing Science Operations System is an absolute marvel of data engineering, turning a firehose of raw pixels into beautifully structured catalogs of our galaxy. With millions of light curves published automatically and with absolutely zero proprietary period, what will you discover? Thank you so much for joining me on this explainer, and I really can't wait to see what you uncover in the data.